All right, guys. Thanks for coming. Good to see all of you on a Friday. Not much better to do outside anyway. It's going to be raining all weekend, so that's going to inspire. I was going to go hiking, but I didn't. The weather wasn't good enough, and so it's just going to be another working weekend, I think, which is fine. I've got plenty of work to do, so let's go ahead and get started. What I'm going to do today is mostly just practice problems. I want to give you some practice problems. Of course, there's a sample midterm, which also has some more practice for you. But the one thing that I regrettably have not been able to do much, usually when I teach classes, I like to do group works and do some extra problems, and I just haven't had time because I've been like scrambling to catch up to what Dr. Converse's schedule said. So instead of doing them during the class and everything, I thought I'd just bring them today, a lot of these problems, and we could just practice on them. And I think it would be a good way to study for the exam and give you kind of the style of the kinds of questions that I like to ask. I've been with you pretty much the whole semester except the first couple of weeks. So, right at the very beginning, you probably learned about vector spaces, sort of what they are, and subspaces, and things like that. So, my mindset kind of with this class, every time I teach 307, my mindset is really that this class should be not just a redo of 250B again, but actually should sort of bring things at a little bit higher level. Having said that, some of the questions that you'll see on the exam on Tuesday or on the sample test, they're going to look kind of just like Math 250B questions. But of course I'm going to expect a little bit better like answers, and now that you have strategies of proof, so there may be, of course, a little bit more proof-oriented questions. I'm not saying that it's all going to be proofs, but there might be more of that than you would get in 250B. And just a little bit higher level of questions. So, I think that in terms of the material itself, you should expect kind of an even, there's basically 8 sections for the test, right? 8 sections because it's the 6 sections of chapter 1, and then 2.1 and 2.2. I think you should expect the material to be kind of evenly covered. I usually am pretty good about covering a lot. Like, it's not like I'm going to leave out a lot of stuff. I'll ask a fair number of questions. I do that on purpose because I want each question to not count that much. Because everybody, occasionally, including myself, will sometimes blank out on something and not be, thinking in the right mindset for a problem, and I don't want that to ruin your exam, right? So there'll be a lot of questions, 5 points here, 6 points there, those kind of things. Not a lot of, 25-point questions. I don't like to do that. There may be parts on the question. I haven't written the exam yet, but normally I'll have like about 5 problems, and then there'll be some parts. Sometimes those parts are correlated, they are related to each other, but if you make a mistake on part A, or if you don't know how to do part A, and then you're worried about the rest of the whole entire question, I will always take whatever you did on part A and use it as a basis for evaluating the rest of your work. So let's say I ask you for a basis for something in part A, and somehow you don't quite get the right answer. Right? I'll still take that answer and I'll use it, let's say for part B, then I'm asking you for the dimension of something or whatever, right? That's related to the basis. Well, if your basis, let's say you have the wrong number of vectors in your basis, right? Of course we'll dock you some points for that, but then whatever that number is, let's say you use the dimension theorem in the next part, but you have the wrong, size of the basis. Well, I'll take your basis and base my grading of that next part on what you put down. So that's what I'm trying to say is don't let one part of one problem like throw off the whole problem for you. Okay, good. I'm really interested to have you demonstrate your knowledge of the material. I care much more about that than I hate it when I see a student who's done a whole page of EROs, and then they realize that something must be wrong, so they go back and they erase everything and they start all over again. Yeah, it might have been, they made a minus sign mistake in one spot, which I might have taken off 1 point for, right? And instead they're going to go back and spend another 15 minutes to try to fix that very minor thing, rather than focusing their time on demonstrating their knowledge on the rest of the questions. So try not to let that happen to you. Don't get sucked into like one part of one problem for a long time, especially if it's just a minor detail that's not working out the way you thought it would. You know, you can just let that go and come back to it later. Of course, if you have time later, you can fix it. But I would rather see you lose 1 point for something that's kind of a minor casual thing than to not finish the exam because you were so obsessed with that one little thing. So this is just a strategy point for taking my exams. I do give lots of partial credit if I can tell that you know what you're supposed to do because you've written enough work that I can make sense of it and say, okay, this person clearly knows that they're supposed to bust out the variables and blah, 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 whatever it is, right? I like to give partial credit for that even if the answer isn't quite right. So I think that that's how you should be approaching this as well. Don't get caught up in the details so much. I'm not saying you want to be careless and reckless with doing EROs or finding determinants or whatever it is that you're trying to do, but don't let that sabotage your time to really do a good job on the whole exam. Okay? So that's my best advice. You know, you'll have the whole entire period plus probably an extra 5 minutes at the end. I'll try to do that. But be here on time. Be here early, please. Like 5 minutes early would be awesome. That way we can get started, give you the full time. And yeah, just do the best we can with it. And we'll see how it goes, okay? All right, so with that in mind, I'm going to give you some practice problems, okay? That's kind of the main thing I want to do. The first one is kind of covering some material that relates to stuff before I took over the class. So I'm going to kind of go back to the beginning here. So my first problem for today is the following, okay? So I'm going to let V equal R squared. Okay. However, I'm going to define addition and scalar multiplication differently than you normally do. If I don't tell you what the operations are on the vector space, you should assume that it's the standard operations. In this case, normally when we add and scalar multiply vectors here, we just do it slot by slot. Okay? But in this case, I'm going to actually make the addition and scalar multiplication different. So I'm going to define addition in V slot by slot. In other words, the fancy way of saying that is coordinate-wise. So in terms of coordinates, okay? And so in other words, it's usual addition, right? Normal slot by slot addition. And for any scalar C in R, I'm going to define C times a point in V. So let's say C times A1, A2 is going to equal, well, it's going to equal 0, 0 if C is equal to 0. And it's going to equal CA1, comma, A2 over C if C does not equal 0. So I'm making up a proposed scalar multiplication here. And the question is this a valid vector space? So the question then becomes that is V a vector space using these operations? And of course, guys, there could be a lot of questions on the test that are sort of a yes-no variety. Yes or no, or is this a basis or not? Is it linearly independent or not? Right? We can ask those kinds of questions. Any kind of yes-no question like that is going to have to be justified. I'm serious. If you just circle an answer, like if this says yes or no and you just circle yes, even if it's the right answer, you will get no points for it. I'm literally 0 points. I would rather see you write, I would rather see you not even get the answer. Not even answer, but write down some stuff that's like important yet relevant, useful information. But that would actually be better. So the more stuff you're writing on the paper, the better here. Okay. So this is going to make us think about the axioms of a vector space, right? So, you know, I always like to start off with the fact that a vector space has to be closed under addition and scalar multiplication. Okay, so I'm not quite sure how this was already explained to you at the very beginning, but closure under addition and scalar multiplication are always the first thing to think about. Is this going to be closed under addition? If it's just usual addition, then it absolutely is. If I take two ordered pairs and I add them together in the standard way, I get another ordered pair back again, okay? So I would just, you know, if I was writing this up as a solution, so I don't even know whether the answer is yes or no yet, but I'm going to start writing down my thinking right now. So closure under addition holds, and that's just because it is usual addition. So I don't even really have to explain that. It's just familiar to us, okay? So CL plus, I'm sorry, I don't know if this is a notation that you guys are familiar with. This is just the first axiom in my mind of a vector space, closure under addition. So this is a CL with a plus on it, okay? So closure under addition. What about scalar multiplication? Is this closed under scalar multiplication? If I take a vector in V and I multiply it by C, okay, here's how we do that. Do I get back a vector that is in V again? Do I get something in R squared over here? Definitely. Doesn't matter in either case. I've got two slots here. I've got two slots here. It's two slots, right? So that is obviously holds from the definition. Okay, so those are, I always think about those axioms first. And by the way, if you're asked whether something is a subspace or not, if you're ever asked about subspaces, remember that really for subspaces, these are the only two things you have to consider. The rest of the vector space axioms that we're going to get into in a minute are always inherited by the subset from V. So V is like the big universe that everything is happening in. And within V, I might give you a set and say, is that a subspace of V? And you really are just concerning yourself with these two issues, okay? Because the rest of the axioms just come for free. Okay, so then what other axioms do we have? You guys remember some other axioms? Did Dr. Commerce do these as kind of the way the book does? So VS1. So this VS1 is the commutativity under addition, right? Now the thing is, actually, if we just look at the addition, it's just usual slot by slot, component-wise addition. So what does that tell you about all of the axioms that have to do with addition? They're going to work, aren't they? It's just going to be, it's because R2 under usual addition satisfies all of the vector space axioms. So that would be VS1. I'm not going to write them all out here. You guys, on page 7 of the book, you've got this whole list. But VS1, VS2 is only about addition. VS3 is about the identity element, which, or sorry, the zero element, which would just be 0, 0, right? Nothing is weird about the addition part. So those four axioms, these all hold since they pertain to usual addition. So because they pertain to usual addition, I'm not going to stop and like check all of those. Okay? I can just refer to the standard addition in R2. Okay, so then let's look at the rest of these now. We have the rest of the axioms involve the scalar multiplication, and that's where we did something weird, right? So this is the focus of the problem right here. Okay? So the VS5, that's just the unit property. That's the one that says if you take 1 times a vector, okay, in this case that would be A1, A2. If you take 1 times a vector, you're supposed to get the same vector back again. Okay, it's the unit property. So is that going to hold here?
Yes.
Okay, if I put C equal to 1 into my formula, right, I do get A1, A2. Okay, so from the formula, I'll just indicate that here, I get A1, A2 back again. So that one is a check. All right, let's see, the next one is VS6. This is the one that says that if we take two scalars, A and B, from the field, I haven't really mentioned, the field in this case would be the real numbers, by the way, because you're looking at R2, so the scalars would have to come from R. So anyway, for two scalars, A and B, if we take A, B, and we multiply that by a vector, so this would be A1, comma A2, the question is, does that equal A applied to B applied to A1, A2? Okay, so let's just look at that for a second. issue here is there's sort of some cases, aren't there? If my scalar is 0, then we have a different formula here, right? We're supposed to get 0, 0. So in this case, how could my scalar be 0? Yeah, either A or B would have to be 0. Well, if either A or B is 0, would you agree that I'll get 0, 0 on this side and on this side? Right? So this is certainly valid if one of the scalars is 0. So maybe I'll just make a note here. This holds if A or B equals 0, since both sides become 0, 0. So that's good. So if A or B are 0, then we're good. The other possibility is, what if A and B are both non-zero? So if they're both non-zero, then let's just calculate what we would have. On the left side, right, in that case, on the left side, if I take AB and I scalar multiply it to A1, A2, according to my formula, which is now going to come from the second line, right, I'm going to get AB, A1, comma, A2 over AB. Okay? This is on the left side. While, let's do the other side of the equation. If we do A dot, the quantity B dot A1, A2, now I have to do it in 2 steps, right? I have to first calculate what's inside the brackets here. That would be BA1 and then A2 over B. And now I take A and apply it to that. So I'm going to put the A up on top of the first slot and on the bottom of the second slot, and sure enough, it does work. It does work again. I just have to show it in 2 steps. In other words, these are equal. So this axiom also works. We're almost done with our whole list of axioms. Okay, here's an eraser. Okay, everybody with me so far? I'm going to try not to use that board on the far right because I don't have a wide enough camera. Actually, let me just erase this first part. Okay, I want to keep my problem up here so I can read it more carefully. Let's look at the VS7. So just make sure you know these axioms. This problem, by the way, this would be too long for the actual midterm, I think, because you've got to check all of these axioms. I might say something like, I might ask you to focus on 1 or 2 or 3 axioms specifically, but to ask you to do a whole entire verification of, basically it's 10 axioms if you count the closure under addition and scalar multiplication. This is too much for an in-class, 1-hour test or whatever. So, okay, so VS7, let's see, this is the one that says that for a scalar A, right, if we take A and we scalar multiply it onto a sum of 2 vectors. So let's say we take A1, comma A2 plus B1, comma B2. This is supposed to equal A scalar multiplied to A1, A2 plus for those of you watching at home, the nice thing is you can always pause and rewind. You didn't get a chance to write this all down. It's nice to have the extra time. Okay, so the next part is A times B1, B2. Okay, so let's just check that. By the way, I still don't know if the answer is yes or no. It's okay. We know that we're going to get partial credit for every little thing that we're doing right here. So we may as well just do this, and then we can answer the question at the end. So on the left side, I'll just call that LHS. Let's see. What I've got to do on the left side is, am I doing the scalar multiplication first, or am I adding the points first? Right, I'm adding the points first. So the left-hand side becomes, let's just put it here, A scalar multiplied onto A1 plus B1, comma A2 plus B2. And that, then, using our formula on the left side, that would be, well, it could be, if A is 0, then again, you're going to get 0 equals 0 plus 0, right? If A is 0, then everything is going to be 0, 0 equals 0, 0 plus 0, 0, and that's clearly true. So can I just run back up here and just note that, let's just consider if A is not 0. Because if A is 0, okay, otherwise, left-hand side equals right-hand side is clear. Don't be afraid to say something is clear. On the test you can do, like if something is clear, say it's clear. Just make sure if it's clear to you, then I hope it's going to be clear to me, because I've known this material for a long time. So just be a little careful. And if you're not sure, you know, it's always better, when in doubt, to over-explain something than to under-explain it.
So in this case, like if we said like A not equal to 0, would that be enough? Or would
Yeah, if you didn't even mention this,
okay.
If you didn't even mention this and you just said if A is not 0, I would give you the benefit of the doubt that you understand that the case where A equals 0 is like trivial, right? So in this case, I would definitely be comfortable with that, because it is trivial. Because if the scalar is 0, you're going to get 0, 0 everywhere. Yeah. So.
If you tell us on the test, like specifically focus on this axiom, and also like VS7, do you expect us to know like which that one is?
Oh, that's a good question. Do I expect you to have the actual axiom numbers memorized? I don't think so. I'm gonna make a decision right now, because this is just our book's way of numbering them. Actually, if you read a different book, they're going to be organized and displayed differently. So I won't ask you to state and prove VS7. I would ask you to state and prove. Well, I would ask you to not state it. I would just say prove, and then I would give you the axiom for that. Okay, but here, I'm not specifying an axiom, so you have to know all the axioms, right? So anyway, so here, I'm going to just get A times this point, which is going to be A times the quantity A1 plus B1, comma, A2 plus B2 all over A. So just using my formula, that's what I would get. Does it look like it's going to be equal to the right-hand side? It actually does. And what you can do to just proceed to the right-hand side is literally break this apart. Right? I can write this as AA1 plus AB1, comma, A2 over A plus B2 over A. And now I can split it into two terms. Right? The first one is AA1, comma, A2 over A. And the second term is AB1, comma, B2 over A. And now you can just take the A right out, and you're getting the right-hand side. So I'm just scribbling this down pretty quickly here, but that's what's going to happen. Okay, which is equal to the right-hand side. Okay, so there you go. That seems to work pretty nicely. I'm not going to expect... Oh, I should have written an A2 right here. Is that what you're going to catch me on? A2? Yeah, thanks. On an in-class test, guys, I'm not going to expect your writing to be perfect, right? You know, it doesn't have to be, you know, as polished as like what you would type up for a, you know, a nice formal paper or anything like that. So you can get to the meat of the calculation. Some people have a tendency to write so much, and then they have this whole big preamble. Some people, I've noticed, they even like restate the whole question, right? This is not what you want to spend your time doing, right? Just get right into the heart of the solution, okay? So that's VS7. There's only one more axiom. So does it look like it's going to work? Don't think so? Okay, I have some people who are suspicious of the last axiom. Let's look at the last axiom. This is the one where we have, it's the same kind of distributive law, except there's two scalars and one vector. So in this case, what we're going to have is for A and B in the field, the question is A plus B applied to A1, A2. The question is, does that equal A times, sorry, A times A1, A2 plus B times A1, A2. Okay, so that's the question. And you can see what the problem is going to be. This isn't going to work. Because the second slot, in the second slot, you have to divide by the scalar. The second slot on the left side, let's assume that A is not 0, B is not 0, and A plus B is not 0, right? So when A, B, and A plus B are all not equal to 0, you see the problem? We're going to basically get, for the left-hand side, we're going to get, the point A times the quantity, we're going to get A plus B times the quantity A1, and then we're going to get A2 over A plus B. That's the left-hand side, but then the right-hand side is going to be A1, comma, A2 over A, plus BA1, comma, A2 over B. And now, using usual addition, the first slot is okay, A plus B times A1, but the second slot, which is A2 over A plus A2 over B, that does not equal A2 over A plus B. These are not equal right here. Okay, so this axiom fails. One of the things I actually really like this problem because it's probably going to be the last axiom that you check that's going to be the problem. By the time you've worked this hard, you're like, oh, it must be a vector space. And then at the last minute, it doesn't work. So it's a little tricky that way, but it's still a nice problem. This would be too long for an in-class test, definitely. But for practicing, I think it's great. Okay. Everybody good with that so far? Okay, so that's, this is just my friendly reminder to go back and review the vector space axioms. Okay, just make sure you know those axioms. Make sure you know the difference between what is an axiom versus what is some other conclusion. So let me just give you one more example. Like there's a bunch of things that follow from the vector space axioms. So for instance, let me call this number 2. Prove that in any vector space V with some vector little v and capital V, -1 scalar multiplied onto V has to equal the additive inverse of V. So this equation is not an axiom of a vector space, but we can prove it from the axioms. And that's what we're being asked to do here. Have you seen, I forget what the first, did it stop?
No, 1 minute left.
1 minute left. Okay, well let me just stop it now then.